Yep, back again with another MC10 video. This time we're gonna take a look at MushFrog, which is a game that I was working on that I didn't quite finish. Big surprise. No, still working on it. I decided to back up and get a little farther on some other stuff before I do that, and I wanted to make it a little more machine language rather than have so much basic in it. So anyway, let's get rid of this, and we will open up this. And now the interesting thing is that I was curious if I could import a game, a machine language program connected to a game by loading it through cloadm. So let me explain. So I take this game, which has both basic and machine language, and I load that. It's called MushFrog Machine Language 3. It has basic and machine language subroutine in it. Not in the game, you won't even see it. It's up higher than that. It's just, and if you list, you can't see anything. But the load address executes, moves basic, makes it then run basic, and runs the game itself, which isn't perfect, but yet it is intriguing. So keys Z through question mark make your frog appear, and you're supposed to catch these little dropping bombs from that mushroom up there. There's no scoring mechanism though, so, and there's no real danger as of yet until I finish it. And there could be like consequences if you don't catch if you don't catch the dropping bomb. And like I said, most of this is written in BASIC. And if you, one of the things that I was going to do is if you let one get past you, it was just going to be a little blue line down there on the bottom, and if you go back on top of that same one, then it turns into a little explosion and makes you explode. And whether that takes down a power bar or what, oops, it's pretty fast, pretty responsive. If you miss, you could also have I'll let that one hit. See, now that, if you were to go on top of that, you could make yourself get hurt. And the mushroom just kind of vanishes and reappears, and it's mostly written in BASIC, that stuff. So I'm going to show you here what the BASIC looks like. We won't be able to see much of it because it's pretty big. So let's see, stop. Okay, I stopped the program. Notice the bomb is still dropping even though the BASIC is stopped. That's because the machine language program is running all the time. Okay, so now we're gonna, can't remember if I can poke out of this or not. We'll try it. Yep. Maybe not. Oh yeah, looks like I can. Okay. So I'll pause this and find the source so you can see it on a listing. And I'll be right back. Okay, back again. Here we are. This is MushFrog2 listing. Clears some string space, a lot of dimensional arrays to show some of the animations or just the graphics. Not too much animation in BASIC because it would really bog it down. It just kind of places the graphic or not, which really made it so I could create a pretty good game in comparison to what you could create without doing it that way. Okay, so now a bunch of variables here. It speeds it up if you have, instead of having the program read 16895, it makes it a lot faster for it to just read M, because M refers to 2 bytes instead of having to convert 16895, which takes quite a bit longer. Anyway, so all those numbers are put up there to speed up the program. And then yeah, we've got some pokes for putting lines in, it looks like. And then I got some good rems here for set mushroom man. And then set mushroom bomb. Set frog catcher. And then rem set key input data. And randomize. Draw the mushroom. It looks like it's setting, it's actually creating the array here for display later. It's not actually putting it on the screen yet. Same with this loop and this loop. And then this would be setting up the randomization of, I'm thinking of where to put it. 10 spots. Or, no, 32, I don't know. But that's what moves it around. I had to calculate that. And draw the mushroom, that's when it places it on the screen. Draw the bomb. All I have to do is put it on the screen in BASIC, and the machine language subroutine takes care of the rest. Very simple subroutine, actually. And remove frog catcher, so you got one that places, one removes. Looks like I am checking the falling blue fall, which would be the bomb. So, and then there's a bunch of data at the end, which is only used at the beginning, and it's a fairly small loop that it sticks to. Let's see, where is it? Anyway, you get the idea, and pretty straightforward little program. It'd be nice if I could put some scoring on the screen and add the rest of it. I'm going to pause it so you can take a look if I can find that machine language subroutine, which is pretty easy. And I will be right back. Okay, here we are back again. This is MushFrog2 code. This is the code, so it's not really MushFrog2. Okay, so the origin is 20480 because that's after screen graphics. And then this one has a little bit of nifty code in it, like I was telling you earlier, and I'm going to try to explain it coherently. MushFrog code start 3, that's the beginning, executes the contents of X, and we jump to start 2. So okay, start. This is going to add the IRQ. It's going to make it so it constantly is able to do stuff all the time. Or it's going to check to see if BASIC is moved. This is what allows me to load BASIC and a machine language program as part of the machine language file, and luckily it's going to be up at the higher address, which means it doesn't interfere. It doesn't lock the machine or anything when you first execute it. It simply just sets the BASIC pointer to where the machine language code resides, except it's not machine language, it's BASIC. And then after or before, I'm not exactly sure. Anyway, where did I move BASIC? Intriguing. Anyway, so then I could check that, but you know, that's boring. So let's just either after or before. It looks like since the origin's 20480, I probably moved it after, like I do on the screen programs that I write. Okay, so now, Yeah, now that basic's moved, it clears the screen. 2 parts of the screen cleared, except for the gobbledygook that Radio Shack so greatly in their wisdom left on the screen for us to hem and haw about. Then test to make it continue after new. That's to make sure that the memory, the basic move is initialized. Okay, then here goes the actual program for checking the block and see how small it is. Start, end. It's not that many bytes. You can even count it through. Oh yeah, X. I was going to tell you some interesting stuff about machine language, which is this means load X. X is the indexing register. This loads X with the value of 19391. Then it loads A with the contents of that memory location. Then we compare A to 105. And 105 apparently would be a, if it is what we want it to be, it would be a yellow, blue, blue, yellow block. And if it is not equal to that, it branches to skip all the way down here. Most of the time it's not going to be equal to that, so then it's going to compare it to the end of the screen, and if it equals that, it's going to exit. It'll LDX with store X and return to subroutine back to basic. Okay, so now we'll go back up here and we'll say, let's say it is equal to 105, and if it is equal to 105, it will not jump to skip. It'll simply just go to this instruction. And so now it'll store the contents of A indexed by X, but this 32 makes it go 32 ahead, so it adds another blue and yellow block right at that position. And then we're going to LDAA with number 85, which happens to be the value of yellow, blue, blue, yellow, and we store that at the indexed position again. LDA indexed with X plus 64, this other one was plus 32, and this, any previous one, I don't see it. There's one that's already there. I think it was set by basic. And so then we compare, let's see, LDA with, not 64, load A with that, compare with number 65, which is yellow, green, green, yellow. Branch if not equal to skip. So that is a normal. There's one little thing that's not quite working. I think when he catches the block, it's seeing if the frog is there, and that's why it's going to clear it basically. So if it is yellow, green, green, yellow, it skips skip. Branch if not equal. So if it is equal, goes to LDA with number 85. Actually, I think 85, I said that wrong earlier, is all yellow. Yep, that's it. So it'll blot out the bomb. And then we're going to store that at that position, which blots out the bomb. And we're going to push X. Load. Oh, this is for scoring, and I don't really have that implemented yet, but that was the idea. So that's it. Pretty simple. And let me see if I can find something else here. I'll pause it, and I'll be right back. Seems so instant, doesn't it? So that's it. Now what I'll do is I will, I'm going to go ahead and, if my computer will cooperate with me, I will reset that. cloadm again. MushFrog ML3. And notice if we list again, like I covered in the beginning, you don't see anything. But if you execute, it actually runs the program. It's pretty cool. And the machine language script. And with little added features here. Somebody want to finish my program? Anybody have any ideas? Notice when that frog catches it, there's a little yellow line between the mouth of the frog and the blue block, which I tried to get rid of, but it didn't go away. And it's kind of a you got to play around with the machine language, assembly language. Oop. Ah! Oh, got past me. See, it can happen. So now if I stood on that little blue block there, it'd be a bomb on my lily pad. I'd be in trouble. So you want to skip that one, try to. And then of course if you had like moves, you could have like a power indicator that would drop if you missed your move. Like if I went here instead of there, I would like take me an extra move, so I'd lose more power. There's a lot of things that I could do to make this an interesting game. MushFrog. That's it. Till next time.